Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology. So today I am going to take a topic on demultiplexer from the unit combination circuit. So under the subject digital principles and computer organization. So what is a demultiplexer? Demultiplexer, it is a combination circuit and can also be referred as a data distributor where the output will be connected to many outputs will be there that will be connected to a single input based on the selection line. So demultiplexer, it is also referred as a DEMUX where it comprises of only one data input line and 2 power n output line and n number of selection line. So similar to multiplexer, the demultiplexer is also the selection line decides the which input line will be connected to the output. There are many outputs, so accordingly the input line will be connected to one of those outputs, right? So it works reverse of your multiplexer. So demultiplexer is also many types. So let us go through each one after the other. So first comes with the 1:4 demultiplexer. 1:4 demultiplexer, it comprises of one input line I and the output lines are being from Y0, Y1, Y2 and Y3. So there are four output lines and two selection lines S0 and S1. So based on the selection line S0 and S1, the input will be connected to one of the four output lines. And hence the name demultiplexer is referred as a data distributor, where the input is being distributed over a different sources. The truth table of 1:4 demultiplexer. As we see, based on the selection line S0 and S1, the outputs from Y0, Y1, Y2, Y3 is laser 1 will be activated at a time for the respective selection line and that will be guided to the input appropriately. When the selection line S0 and S1 both are 0, the output line Y0 is being connected to the input. When the selection line S1 is 0 and S0 is 1, output Y1 is being connected to the input I. When S1 is 0 and S0 is 0, output Y2 is connected to the input. When both selection line S1 and S0 are 1, output line Y3 is being connected to the input. So as we see from the truth table, at a time only one output line is being connected to the input, data input. The basic gates have been implemented for this logic. So for the logic Y0 is S1 S0 I and Y1 is S1 bar S0 I and Y2 is S1 S0 bar I and Y3 is S1 bar S0 bar I, and all these Boolean functions are being implemented using the basic AND or and NOT gates. So next comes with the 1:8 demultiplexer. 1:8 demultiplexer, it comprises of one input line followed by three selection line and eight output lines from Y0 to Y7. So based on the selection line, the input is connected to one of the respective output lines from Y0 to Y7. So this 1:8 demultiplexer has been implemented using the first stage, a 1 to 2 DEMUX stage has been implemented, which the data input I based on the selection line S2, it, it will be guided to one of the two output lines. And the output of 1:2 demultiplexer is being connected as the input of 1:4 demultiplexer in the second stage. Whereas in the second stage we use two 1:4 demultiplexer and two selection lines. Right? So based on the selection line, the 1:4 demultiplexer will guide this one input to one of the four output lines. Truth table of 1:8 demultiplexer. As we seen in the previous block diagram, the selection input S0, S1 and S2. Based on the selection line, the outputs from Y0 to Y7 at a time will carry only one data input line over the multiple output line. Say for example S0, S1, S2, when all the selection lines are 0, the input will be guided over the output Y0. When the selection line S0 is high and S1 and S2 are 0, the input will be carried over the output line Y1 and so on. When we say for the last S0, S1, S2, when all three selection lines are high, the output Y7 will carry the respective input. What is the advantage of such demultiplexer? So demultiplexer, it could increase the efficiency of a communication system since one data input is being transmitted over multiple input sources. It can be connected, right? And it can also be used for signal separation from a mixed signal stream. And this is also being used by the multiplexer. Similar to multiplexer, it is being used for decoding purpose. Demultiplexer, it also decode the signal which is being produced from the multiplexer. And applications of a demultiplexer is used for data routing, and this can also be used for the design of arithmetic and logical unit, right? Arithmetic and logical unit, it can also be referred to design a parallel to serial converter circuit, right? And this system is efficient in transmitting a single signal over a multiple data streams. And the assessment questions have been discussed in the previous slides of this video, so kindly go through. So what is a demultiplexer and design of 1:8 multiplexers and then applications of a demultiplexer. Thank you.